Okay, in this video, we're going to continue talking about pressure. We're going to talk about a barometer or barometer. You've probably heard of barometric pressure if you ever watched the news, or maybe your dad or your grandpa has a weather station, because that's what old people like us do. You have nothing else to do but watch the weather. And if you watch the barometric pressure go up and down, it can predict weather changes. Well, what is a barometer? So let's draw a picture. Well, let me give you the definition. Whoa, hello. This measures atmospheric pressure. Okay, it just simply measures atmospheric pressure. Baro, the Greek word is baros, I think, that comes from, and that just means weight. So a barometer is a weight meter or something that measures weight, and specifically we're talking about the atmosphere. So let me draw you a really bad drawing of a barometer, and we'll understand, this will help us understand where the units we're going to deal with most often come from. Okay, so we're going to have a dish here, and in that dish there is a glass column, kind of like a big giant test tube. This thing is really, really tall, okay? And the way this is made, if you were actually going to make this, and I remember this because my high school teacher told me that they actually did this in her elementary or junior high science class. You're going to freak out when I tell you what they did, but they took a big long glass tube. It has to be about 1 meter long, about 3 feet long. Fill it full of mercury. Okay, so it's right side up. You fill it full of mercury, and then you have a dish full of mercury as well. This is mercury. And what you do is you invert that glass. You cover the glass with your hand. This is how they did it in my teacher's class. Put the opening and their hand in the mercury, took their hand away, and what happens, so yes, their hands were immersed in mercury in elementary school. What happens is the column of mercury falls a little bit, but it doesn't fall all the way. Now this is not to scale or anything like that. This isn't exactly how it would be built, but this gives you the idea. And up here, what is there? Well, it was mercury. The tube was completely filled with mercury. It was plunged under mercury, so there's nothing up there. That's a vacuum, and vacuum is a really weird word. It has 1 C, 2 U's. I don't know, it's the only word I can spell right. Okay. Now, what you can do, let's talk about atmospheric pressure. That 101 kilopascals atmospheric pressure is pushing down on the surface of this mercury, okay? All over the surface of this mercury. So per square meter, there's 10,300 kilograms of air pushing down on it. That's what prevents this column of mercury here, this column here, from falling all the way down. All right, and because of that, if we measure the height, whoops, let's undo that. If we measure the height of that column of mercury from the tippy top of the column to right there, the surface of the mercury, and we call that height H, that is equal to 760 millimeters of mercury. Okay, and that is our unit of pressure, atmospheric, or unit. That is a unit of pressure that we use often in this class. Okay, so let me give you some definitions of units based on that. So 1 atmosphere, 1 ATM, that's just atmospheric pressure, is equal to 101,325 pascals, which is equal to 760 millimeters of mercury, and now we know where that comes from, which is also equal to, there's lots of units for pressure, I'm not sure why, 1.01325 bars, which is also equal to, here's another one, 760 torrs. This is named after Italian physicist Torricelli. And let me say one more thing about these. These are all exact conversions. So what that means, they all have infinite sig figs, all these values. And they are all equal to 1 atmosphere. So you may need those. Let's see. So that's a barometer. That's how we measure atmospheric pressure. Okay. And here we're going to talk about what we call it's not a manometer. I know some of you are hoping. It's a manometer. Okay, manometer. This measures, that's another bad joke, sorry. They don't stop, do they? Measures the pressure of a gas sample. And for these to be useful, you have to know atmospheric pressure. So we say atmospheric pressure is normally 760 millimeters of mercury. That's kind of the mathematical or scientific definition of 1 atmosphere, but that can vary depending on the day. So I have a nice sunny day. The weatherman will say we have high pressure in place. That means the pressure might be above 760. We have low pressure, kind of a rainy day maybe. The pressure might drop below 760. You go up in elevation, there's less air above you, so the pressure drops then too. You go down in elevation, say you go to the Death Valley, where it's below sea level, you'll have more air above you, pressure will go up there too. So you have to know your local atmospheric pressure for a manometer to be any use to you. Now we don't really use these anymore because we have all sorts of fancy electronic things. But anyway, we'll still talk about it because, we don't ever change. We like to do things the same way we have always done them. So I don't know what that looks like to you, but that is a glass, that's a flask, okay? In this flask, we're going to put our gas sample, and then inside of that flask, inside of that U-shaped tube, this is a U-shaped glass tube, we're going to put some more mercury, okay? And here we'll have PATM, okay? So what we can say here is that in this instance, PATM is exactly equal to P sub gas, just the pressure of our gas, okay? They're the same. Now, if we somehow add some gas or take away some gas, that will change. So, or we can just simply increase the pressure of our gas. We don't even have to add any. We get to heat it up. We'll talk about all that sort of stuff later. Okay. There's another flask. And here we have our gas. And the gas exerts pressure. We'll talk about pressure later. It exerts pressure uniformly throughout this tube. Now, in this case, we've increased the pressure. Don't worry about how or why. It's just what we're doing. Mercury. Okay. Then let's see, we still have PATM. PATM. But now we have a height difference again. So let's draw that. So now we can say that the pressure of the atmosphere is less than the pressure of the gas, because the gas is able to push the atmosphere back with the mercury. Now if we want to write an equation, we got to include H in there. So the pressure of the atmosphere plus H is equal to the pressure of the gas. All right. Now let's do the same thing, but reduce the pressure of the gas. So the gas, we have our gas still in there. Oh, I forgot to draw the rest of my flask, didn't I? Or the rest of my manometer. Okay, we still have PATM pushing down. Now this time it's going to be the opposite direction. Still mercury. And the gas is still exerting pressure and it's pushing down on that mercury. But now the atmosphere is able to push back against that mercury. We still measure that height difference. And if we measure it in millimeters of mercury and the pressures are all in millimeters of mercury, we can just simply add. Okay? So this time, the pressure of the atmosphere is higher than the pressure of the gas. And we can say, we can just move H basically over to the other side. So we can say, let's see, PATM is equal to pressure of the gas plus H, because that column of mercury is exerting pressure as well. That's it for now. It's a manometer and a barometer.